Let's do an example that puts together all the things that are degree, leading coefficient, and behavior, x-intercepts as well as y-intercepts. So go ahead and write this equation down. Y equals x plus 2 to the third times 3x minus 1 to the second power times 1 minus x. The reason why I chose this problem is the leading coefficient is actually harder to find. You'll notice that this last one over here, 1 minus x, is kind of written backwards. You're used to seeing that x written first, and because of that, we have to actually factor out a -1. So anytime you have a negative in front of the x, you got to factor out that -1. Factor out the -1. So I'm going to write that down so you know to do that. If you do that, you've got still the same thing at the beginning here. None of this has changed. Sorry, that's a 3. And then now this factor will change to an x minus 1 if you factor out a -1. And I'm actually going to put it in the front, the -1 that I factored out, just because it's weird to write it in the middle. Sometimes people think I'm just randomly subtracting 1 in the middle. Now, because this function is written in factored form and not standard form, to find the degree, I have to pretend if I multiplied all of this out, which I'm not going to have you do, what would be the highest exponent for your x? So if I multiplied x to the third from here, x to the second from here, and this is technically x to the first, if you did x to the third times x to the second times x to the first, that would be a total of 7 x's, right? Oh, no, just kidding. It would be a total of 6 x's. So I'll just write it out just so you can kind of see. This is like the maximum number of x's you'll have when you multiply all of these out. So your degree will be 6. Now, I'm not going to have you sit there and actually multiply it out because it really won't be helpful. But I'm going to write down my degree is 6, aka it's even. So I'll write that down too. That should narrow down what you think your end behavior is. LC stands for leading coefficient, if you recall. Now, if you look at the leading coefficients, they're all kind of positive here. Here's a +1, here's a 3, and here's a +1. If I really wanted to find it out, I would just multiply all of these coefficients of the x. -1 times 1 times 3 times 1 happens to give me -3, but the only thing I really care about is that it's a negative. So I'm going to write down it's negative. So when I ask you for leading coefficient, I actually just want to know if it's positive or negative. Now, combining the fact that you know your degree is 6, which is even, and your leading coefficient is negative, the end behavior, all I really actually want you to do is draw what the arrows should look like. So even degree means they're pointing in the same direction. Leading coefficient negative tells you that they should be both pointing down. All of this is quite important for you to be able to get those. Otherwise, the rest of them won't turn out well if you don't get these ones correct. Next one, x-intercepts with multiplicity. So what I'm going to do is I'm going to set each of these factors equal to 0 since this is already in factored form. Each of them have different multiplicities in this example. So we're going to talk about what that will yield. You can do the x minus 1 instead of negative or 1 minus x, but it will still give you the same answer. So it really doesn't matter to me which one you're solving for here. But looks like here are my 3 different x-intercepts that I get because I'm setting, it's essentially like when I'm setting each of these equal to 0. When my y is 0, here are the 3 different options I get. So this x plus 2, notice this occurs 3 times because it's kind of like x plus 2, x plus 2, x plus 2. That makes my multiplicity here 3. If you recall, a multiplicity that is odd will act like an odd function going through there. So it's going to cross, but I'm going to write down that it will squiggle through. If you recall, x to the third looks like this kind of graph. See that squiggle in the middle? That's exactly what it's going to look like when you're graphing it at -2. At x equals 1/3, you'll notice that this factor only occurs twice. 3x minus 1 has an exponent of 2. That means this one has a multiplicity of 2. So it will act like something with a degree of 2 at that spot, aka it will bounce or touch according to the way that your book likes to say it. So it'll kind of act like a parabola, right? A degree of 2. It'll do like one of these. It'll touch the x-axis and it'll come off from it and go back from where it came. The x minus 1 / the 1 minus x, that only occurs once, so that has a multiplicity of 1. If you recall multiplicity of 1, It's going to also touch slash, I'm sorry, not just touch, it'll cross through, but it'll act like something with degree of 1, aka it'll act like a line. So it's just going to go straight through at that spot. The last thing before we actually sketch it, I would like to find the y-intercept so I can kind of sketch all of them all at once. The y-intercept is just found by putting in 0 for your x value. So I'm going to say y equals, you can put it in the original, 0 plus 2 cubed, and then 3 times 0 minus 1 squared, and then 1 minus 0. Let's calculate that. Don't forget those exponents. When people forget those exponents, it completely changes what the value of your answer is going to be. So looks like I got 0, 8 as my y-intercept. Now we're ready to do a sketch. So the only 3 points that you actually have are these x-intercepts and the y-intercept. So I'm going to go ahead and go down here. I'm going to create a nice pretty graph here. I'll go up 3, 4, 5, 6, 7, 8. Was that 8? I think that was 7. 1, 2, 3, 4, 5, 6, 7, 8. So here's my y-intercept. My 3 x-intercepts, -2. So here's -2. There's one at 1/3. So here-ish. And then another one at 1. Okay, so for our sketch, this part is kind of tough for people. You have to look at your end behavior. Remember, the arrows are coming from the bottom, and you have to make sure that both of them are pointing downward. So I'm going to go ahead and start my graph down here and say, hey, these are what the arrows should look like in the end. Now we have to be careful about what happens at each x-intercept. The thing that's nice is these actually go in numerical order. So at x equals -2, you have a multiplicity of 3. So when you get to this -2, you're going to squiggle through it like that. All right, you see how just ever so slightly, it's not like I'm just going straight through it. If you feel like it's not obvious, you can always write this and say, hey, I'm trying to squiggle through there, because that's important that you know that should happen. Looks like the next point I'm going to hit is going to be my y-intercept. Now, you don't know if it's going to actually max out there or if it's going to go up and then back down, but you'll have to determine that. Eventually, you'll go back down to the 1/3. Notice at the 1/3, I'm going to actually make this skinnier. At the 1/3, it will come back down. It will bounce off of that 1/3, so I'm going to just touch it. At some point, it's going to max out and come back down, so it could reach this x-intercept, and it's going to cross through. Notice I didn't squiggle cross through that, mostly because it doesn't have a degree that is 3, 5, 7, etc. So this is my sketch for that graph.